I am asking a question. This ROM, the 8051 will use for what?
For storing programs.
Program code to access, right? And if you go for this RAM, this particular RAM, the 8051 will make use for data, datas to store or to read. These are the two operations. But program code to access means program code to read only. Is it okay? Now, for the ROM, a program code to access, which is the one pin that 8051 will make use, that is PSEN bar. RAM to access, it will use either read bar or write bar signals for reading or writing purpose. So now how do we illustrate all these things? When the 8051 will access the address and when it will be accessing the data. So for that, let us write the timing diagram through which we will be understanding when the code will get placed onto the 8051 or data will get placed onto 8051. So for that, let us take first, whenever the 8051 is interacting with the RAM or ROM, it has to identify address. So whenever it has to identify address, address has to be placed. Identification of address, for which 8051 depends on the port 0 as well as port 2. Depending on what is the capacity, number of port lines will vary. So whenever this port 0 it is using, it is a multiplexed bus. It has to distinguish whether it is address or data. So whenever the 8051 has to address, it makes use ALE. And port 2 directly need not to be demultiplexed. It will be address only until PSEN bar, becomes 0. This you have to remember carefully, and through the diagrams you have to understand how this will do. So first, how this 8051 will identify the address. For that, as I told you, it depends on port 0 and port 2. So how do this port 0 or port 1, port 2 will be representing means through a bus. So bus is nothing but group of wires. How many wires we are going to connect as in port 0? See, port 0 is holding the data or address. How many bits bus pins you have connected to port 0?
8, ma'am.
8. So these 8 pins I am representing as port 0, which is nothing but port 0.0 to port 0.7. All these 8 individual pins, when I combine, this is the structure we are going to make use. So this particular P0 contents will initially convey the address, that is A0 to A7, based on how it will be explained here. So later, after some duration, it will convey D0 to D7, that is the data. So now let me explain this. This is the port 0. Initially, first to identify the address, if and only if the RAM or ROM address is identified, then only the program or the data contents will be able to fetch by the 8051. For that, it is using port 0 as well as port 2. So now another port contents which needs to be taken care by the 8051 is port 2. Port 2, it will be having the address, that is A8 to 15 with respect to time only. Here you have to consider this is with respect to the clock pulses, like this it will be varying. Okay, now A0 to A15 will be available with this complete duration. Okay, now how do the 8051 will access the program or the data? So first it has to identify the address, right? For which is the pin that the 8051 will use? Address must be delatched from here, demultiplexed, for which it uses ALE. So ALE pulse, and once it is going high, then whatever this particular port 0 contents will be there, that will be considered as the address. So this is ALE. Okay, afterwards it goes to low. Next, the program or the data, it will be distinguished with following pins like this. So this is address latch enable. Okay, once it goes to high to low, then only address will be read by the 8051 from A0 to A7 lines. Next, program, whenever 8051 has to access the program data, minimum of 1 clock pulse duration. Here you can see, look at here, PSEN bar. So whenever PSEN bar goes to low, then this particular PSEN bar will read the data from program memory and places onto D0 to D7. Is it clear, students?
Yes, ma'am.
Wherever you get doubt, you please ask me so that I'll explain. Next, if suppose the RAM contents needs to be accessed for read purpose or write purpose, so for which it can make use the same read signal or write signal. Both are active low signals only. Please look at here. This is read bar signal and this is write bar signal. If read bar signal is going active low, this is read data from 8051 on to the D0 to read to the 8051 D0 to D7 contents from memory specified address to the of the RAM memory on to the D0 to D7. This is also read only. If suppose write signal goes low, then it is write data to memory. Read data from memory. So can you tell me the arrow? This write data memory means now whatever D0 to D7 will have, that contents goes to external memory. Is it clear, students? The timing diagram?
Yes, ma'am.
Yeah, other students please respond.
Yes, ma'am.
Okay. No doubts with respect to this?
No, ma'am.
Okay, can
No,
I
ma'am.
move forward? Yeah. So this is about your read, write, or the memory, everything you can consider with respect to the module 1. So in the module 1, what are the topics we have discussed so far? It is one is the 8051 microcontroller, microprocessor, differences. Then we have gone for the embedded systems, difference. Then we have considered, what are the other topics we have discussed? internal architecture, pin diagram, program memory, RAM, then external memory interfacing, ports, and then finally we have concluded with external memory interfacing. Now let us go for the module 2. So the very first topic of this module 2 is the addressing modes. Okay, what do you mean by addressing mode? Before we understand this addressing mode, let us discuss some introduction about this particular topic. When you take that introduction, why do we need to study this addressing mode or instruction set of 8051? Before we start understanding this addressing mode, what type of introduction should we know before we understand the addressing modes is that the first point you have to know is that the program. What do you mean by program? Program definition. So how do you define a program? Program is nothing but what? Set of instructions tells microcontroller or a computer to perform certain task. Students, is it clear? Students. Yeah.
Yes, ma'am.
Please respond. So program, how do you define, means a set of instructions, because addressing modes, when you want to understand few preliminary things you must know. So prerequisites. One is the program. Program is nothing but set of instructions tells the microcontroller or the computer to perform a task. So this task, whenever a program to the microcontroller or the computer, when it is given through set of instructions, when it is given a task to perform, will this microcontroller or the microprocessor or the computer will understand these instructions directly? No. Set of instructions by the computer, the set of instructions will get understood by, how do the microcontroller, what type of language it will understand? Machine language. Yeah, machine language. This machine language is nothing but the binary zeros and ones. So binary zeros and ones. But these binary zeros and ones are not user friendly. Am I right? Because if I write some code 8-bit data 0 1 1 0 1 1 0, can you tell me what this particular code, when it is given to the micro controller, it does and task? Can you able to tell me?
No, ma'am.
It is impossible. So therefore, at this stage, since it is the language that the microcontroller or the computer will understand, that is the machine language, it is not able for an user to user friendly, for which we have devised different languages. The one is assembly language and the other one is machine language. Sorry, the other one is high level language. Any one language can be used. Whenever the high level language you are talking about, it is an example which is C, C++, your Java, your SAP, etc. These are all the Fortran, everything. It is the examples for high level language. Here also, through instructions only we will be giving the task through a program. in the assembly language. It is not C, C++. What we'll be using, the English codes we'll be using. Here, English codes. Here, English codes we will be using. What these English codes are termed to be means it is mnemonics. Means these English codes, also termed as mnemonics, are these mnemonics are used. What these mnemonics means? English like words. English like words. General using words will be compressing and we'll be using some sort of word like structures. Such terms are termed to be the mnemonics. These mnemonics, whenever we are using in the program, mnemonics forms the program. It is termed to be the assembly language. So you have machine language, you have assembly language, you have high-level language. But why do this assembly language? It has been given for you to study in this particular semester. There are advantages of assembly language. What are those advantages? So first advantage is that code will be very small in size. Code is smaller in size. Smaller size. Okay, smaller size. Then what is second one? It the speed of computer. It speeds up computer. Computer or your microcontroller. Means task will be at faster rate. Task performance will be at faster rate when you make use this assembly language. The third advantage is that in memory, program memory, that is wherever we are storing the program memory used in program in memory, less space or less memory is used. Less space is used by this assembly program. That is the reason why we'll go for always these assembly languages. And why this is particularly using less space means the entire program will be represented in the ASCII code. So this ASCII code in turn will be used to control your robots. Okay, robots, then locking systems, then mobile phones, etc. These are all the examples wherein we can make use this assembly language control through the ASCII codes. So these are the advantages. Hence we'll go for the assembly language. Any doubt till this point?
No, ma'am.
Okay. Now moving on to the next. Whenever we make use these machine language or assembly language or high level language, the syntax of instruction must be known. So what is this syntax means? Whenever any instruction, when it is given, there is a specific format that has to be followed. In general, only we are talking now onwards assembly language only. So in this language, in this assembly language, the instruction, any instruction will be represented as follows. So there will be a label field, followed by this there will be a colon, then mnemonic field, followed by this operand or operands field, followed by this there is a comment field. So totally if you observe how many fields any instruction will have. If this is an instruction format, how many fields you can see? One is label field. The second part is mnemonic field. The third part is operands field. Fourth part is the comments field. So how many subfields in an instruction of 8051? 4 fields it will have to define any instruction. Then what is this label is? This label, when you are considering, label is a address of instruction. Address of label represents address of instruction. Means in the ROM space, when the program is coded, program is stored. So code 1 means instruction 1, hexadecimal code, instruction 2, hexadecimal code, as YY, like this everything it will get stored. This instruction 1 will have some address. The address of any instruction will be termed as the label. Is it clear, students?
Yes, ma'am.
How about other students?
Yes, ma'am.
Yeah. The next field, that is this is the first field. The second field is mnemonic field. What is this mnemonic field means? It is the symbolic representation of the task or English word to computer or microcontroller to specify what job the controller has to perform. What job to perform. Okay. Next, the next third field is an operand field. I'll give an example. This operand field. Operand means there will be an sometimes one operand or sometimes two operands. Instructions you will see with one operand also, two operands also. So one operand it will add source and destination, but two operands source and destination separately. What do this operand tells means what the job the controller has to perform and what operands it has to perform will be specified in this operand field. Operands are the datas. Operands are the datas on which job has to be performed. What job? How do you specify? Through the mnemonic. So through the mnemonic, whatever the job it has been specified, that job and the operand it will be operated or it will perform. So therefore, operand fields needs to be mandatorily represented. This particular fourth field is a comment field. So usually in C++ also you have used comment field. What is that comment field? What's the comment field?
To indicate any
It is
other
an,
extra
yeah,
code.
each instruction, what it does, what job it does, its explanation you are going to give. Explanation is through the comment field. Now, in this, what are the mandatory fields and non-mandatory fields? If you look at this label field, it is optional. If you want, you can make use, or if you don't want, you can leave. The fourth field is also an optional field. If you want to give user-friendly code, you can write this command for each statement or each instruction otherwise, but mandatory fields are the mnemonic and the operand. These two are mandatory fields. Clear, students?
Yes, ma'am.
Yeah, instruction, is it clear? Now, examples for how this what is the example of this instruction? For that, let us take only the mnemonic field and the operands field. Move A, hash 56H. This is one example for, oh sorry, move ಕಟ್ ಮಾಡಿದ್ರ. ಹಲೋ ಸರ್ ನಮಸ್ತೆ, ನಾನು ಕ್ಲಾಸಲ್ಲಿ ಇದ್ದೀನಿ, ಇನ್ನೊಂದು 10 minutes ಬಿಟ್ಟು ಫೋನ್ ಮಾಡ್ಲಾ? ಹೌದ್ರಾ? ಆಮೇಲೆ ಮಾಡ್ತೀನಿ ಸರ್ ನಾನು ನಿಮಗೆ. ಓಕೆ ಓಕೆ. This example, it includes move A, hash 56 is one example of an instruction. The second example that you can take is add A, R5. These are the two examples of instruction format. So what is this first field of instruction? It represents mnemonic, and these two fields represents operands. Whenever the mnemonic and the operands you are writing, minimum of 1 space it is required for mnemonic as well as the operands to distinguish, whereas operands through an comma operator you have to separate. This is the syntax that you need to follow. Now, before we go for these addressing modes to understand completely, one more point you have to remember is that when through such instructions, when a program is written, what exactly the 8051 controller will do on this program, because program when we write, it is set of instructions. These set of instructions, when it is given, it may be given, we know that it may be given in assembly or it may be given in high level language. Whenever high level language or assembly language, we make use and set of instructions as a program when it is given. In 8051, when assembly language is considered, let us see how the process will, assembly language is used, how the process will be done for the machine to understand this program, what process it will apply to understand the program. For that, the assembly language, when it is written, this assembly language, it should go to an editor. So first, initially you need to save the program onto an editor. You can go for MS-DOS editor, or you can go for a notepad as an editor or TextPad as an editor. Any sort of Microsoft Office notepads you can make use. But when you are saving this program, it is always important to save this program in the assembly language, if the program is in assembly language, with an extension of .asm. And after this editor, it is edited with the program, you will be applying the assembler. The function of this assembler is to convert the assembly program into an object file. It will convert, the output of this will be an object file. So this object file, sorry, the output will be an object file, and to this object file .obj, we'll say .obj, we will be adding an linker program. Linker program means to the original file obj, this object file is nothing but it will be in the form of hexadecimal codes. Okay, these hexadecimal codes along with other object files, when they have to be linked, files needs to be linked, the next program that will be running is linker program. When the linker program is applied, the object file, it will get converted, complete object file will get converted into hex file. So what is the output of the this linker program is hex file. This is where this hex file is nothing but 8-bit binary number. So these numbers the 8051 is able to understand. So this is what the process that any program when it is written in assembly, the 8051 will make these steps or use these steps to convert and makes this hex file, creates this hex file, which is an machine understandable code. Clear, students? Students, is it clear?
Yes, ma'am.
Yes, ma'am.
Now, whenever this 8051 is able to understand only the binary, what are the data types? Another 5 minutes are there. I'll finish off this data types. What are the various data types it will make use means? It uses only 8-bit binary number. So this 8-bit binary number, when it may be used as 1 byte or sometimes to the program to fulfill more than 1 byte also needs to be used. So how do these bytes will be given to an microcontroller? That is what we'll study in data types. So whenever these 8-bit number or 16-bit number or 32-bit number, when it has to be specified for microcontroller, it uses assembler directives. So these assembler directives, what exactly they'll do means, these directives are nothing but pseudo instructions. These pseudo instructions function is that it will tell assembler rather than the controller. So please, it tells assembler to do what function, what work, to do what task. So since these assembler directives are used mainly to instruct the assembler, there are 4 different pseudo assembler directives. These pseudo instructions, why these pseudo instructions means, hex code, whenever these instructions are executed by the process flow like this, no hex code won't be generated for each of the program. So that is the main difference between an assembler directive instruction and an instruction. Okay, now 4 assembler directives are there, which will tell the assembler directly to does what operation. First one is DB. So this DB is defined byte. It tells the assembler to make use 8-bit data, defined byte. So what is the syntax? It is DB followed by data 58. So it is data 1 colon DB 58H or data 2. Different byte, hexadecimal, decimal, binary, ASCII, everything you can specify through this DB 70. Okay, DB 36. So this 36 does not append with any of this suffix. It tells that it is a decimal. So H, when we are representing, it is an hexadecimal. Okay, data 3, it is DB. Okay, 10110111. It is binary. It represents, it is an binary 8-bit data. Data 4, So whenever we have to represent a 8-bit ASCII code or hexadecimal or string, you can specify within this 5, 6, 7, 8. So what is exactly ASCII? All those things I'll explain in the next classes. So this is first one. The next assembler directive is ORG. So this ORG directive tells the origin of the program in ROM or EPROM, from which starting address program is stored, that will be explained. So syntax is org 500h. In the ROM, the below whatever it is going to be specified as instructions starts from 500h. So this is the second one, and the third assembler directive is equate. Whenever some constant needs to be assigned for any constant, then we can make use this equate. So this equate is used to define a constant, so without storing in memory. So how do we define? Means count, equate it to 5. So directly we can make use move R3 comma hash count. So 5 will be directly assigned to this R3. So this is what equate. The fourth assembler directive is end directive. This end directive will tell end of program. Below this instruction, whatever the instructions, see, you will be writing instructions for a program, and at the end you will be using an end statement. Afterwards, if you try to write some instructions, these will be ignored by 8051. So these are the assembler directives you have in 8051.